Hello class. Today we're going to be talking about dividing polynomials. So far we've added, subtracted, and multiplied polynomials, but we never got into dividing polynomials. And the reason why we haven't is because it's a little trickier than the rest. And the method that I like to use sometimes is when dividing polynomials is called the box method. So we'll be using the box method. We write out a box every time. It's just kind of to help keep us organized. And so yeah, let's get into it. But first, let's recall a multiplication table, because the box that we're going to use works kind of like a multiplication table. So we have these numbers on the outside on the left, and these numbers on the outside on the top, and they are like coordinate points. Like 1 times 3 gives us 3. That gives us the answer, right? 2 times 3 is 6, right? 4 times 3 is 12, and so on. So this box that we're going to use works just like the multiplication table. So what we're going to have is think of what makes up multiplication, or think of what makes up division. We have some product is equal to some function times another function, right? And so what we get, like for instance, let's see if I can try to explain this. Like 6 equals 3 times 2, right? If I go ahead and divide 6 by 3, I get 2. If I divide 6 by 2, I get 3. So we're going to be given one of the factors, and we want to try to find what is the other factor. So that's essentially what we're doing here. So let's just get into it. It takes some practice. Now, mind you, it can be pretty tricky. So just take careful note of what we're doing, and of course, if you have to, you can just pause it or rewind it, whatever you need to, since it's a video. So let's just get into it, and let's do a few examples. So first, we have x cubed plus 5x squared minus 4x minus 20 divided by x plus 2. So as I said before, think of our multiplication. Our two products here, 3 times 2, they go on the outside, right? And on the inside of the box, we get our value. That's how this is going to work. We're going to have one function, we're going to have one of our factors, the x minus 2, what we're dividing by, we're going to want to put it on the left. So an x and a 2. And this is going to eventually go inside of here, but we need to figure it out. And so our answer is going to be up here on top. So I'll show you what I mean. So first step, what we're dividing by, write it here on the left. And then the second step, whatever the first term is, whatever the leading term is, in this case it's x cubed, just put it in the top left box there. So this is how we're going to go. We're going to fill it out like this. So we're going to go, let's see, well, let's do it first, and then we can kind of, well, no, I'll just write it so we have this reference. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 if we need to. So this is the order that we're going to be filling it in. So we already have our first one here, and it's going to work like a multiplication table. So let's ask ourselves, x times what gives me x cubed? Well, that's going to be x squared. And if you're ever not sure, just think multiply them back together. X times x squared gives us x cubed. Okay, so this is a multiplication table. So let's continue filling this out, because we can now. X squared times 2 is going to go right in here. So that's going to be 2x squared. So now, this is what we want to do. We want to go diagonally. So we're going to go from 3 to 4. So we're going to go up here. And what we do here is we need to make sure that these two boxes add up to our next term. So whatever the variable is here, in this case it's x squared, we need to find some x squared value here that when we add those two together, it gives us our x squared term up here. So let's think about this. 2x squared plus what gives me 5x squared? Well, that's going to be 3x squared. right? And if you ever want to validate it, just think 2x squared plus 3x squared is 5x squared. So I think we're kind of working backwards here, right? Okay, so now that we have this, it kind of like a reset. We can figure out this now, because this is multiplication now. So up and down, left and right is multiplication. Diagonally is addition. So x times what gives me 3x squared? Well, that's going to be 3x. And now we can fill this one out. So 3x times 2 is 6x. And then now that we've filled that out, we want to go diagonally yet again, and we're thinking addition. So we have 6 x's. We want to know how many x's we need to get negative 4 x's. So let's think how many x's we'll need. We'll need negative 10 x's, right? Because 6x minus 10x gives us 4x. So now that we have this, we can fill out this on top here. So x times what gives me negative 10x? Well, that's negative 10. And then 2 times negative 10 is negative 20. So what we end up with here is negative 20. And if it matches up with this, if it matches up with your whatever constant you get, if it matches up with the constant in your original function, then there is no remainder. Just remember, in division we have remainders sometimes. So our answer is this up here. So this polynomial divided by this polynomial is equal to x squared plus 3x minus 10. And that's it. And if you wanted to multiply your x plus 2 times this again, we'll get back this. So, cool stuff. I know it's probably still very confusing, so let's go over some more examples. And more often than not, we will actually get a remainder. So let's talk about what that's going to look like. Just like when we divide, we're more often than not going to get a remainder. So what if we have a remainder? Well, let's go back to just division and how we treat remainders there. So here, let's see, division, 19 divided by 2, we can't go here, so we have to go over here. Let's see, 2 goes into 19 9 times. 9 times 2 is 18. Subtract, so we have a remainder of 1 here. Well, I'm not sure if you're aware what we do with remainders, but technically, we add the remainder, and it's going to be 1 over whatever we divided by. So in this case, it's 1 over 2. Say if we have something like 16 divided by 3. Let's see, 3 goes into 16 5 times. So 15 minus, or 16 minus 15 is 1, so it's going to be plus 1/3. So if we have a remainder in polynomials, whatever the remainder is going to go above whatever we divided by in the same fashion. So I'll show you what I mean. So let's do this example. So again, first step, whatever we're dividing by, we want to write it here on the left. So x plus 1 is going to be x and 1. And then our leading term, whatever it is, 3x cubed, goes in this top left box. So remember, this works like a multiplication table. So I know that x times something is going to give me 3x squared. Well, that something is going to be 3x. And then I can fill this in. 3x times 1 is just 3x. And then remember, this is where we go diagonally now. And I know that this box, oh, I goofed. This should be 3x cubed, isn't it? So that means this is going to be 3x squared and this is 3x squared. Yeah, sorry about that. So now we need to go diagonally. And I know that this plus something else is going to equal this negative 2x squared. Well, negative 3x squared, we'll have to think. 3x squared minus what gives us negative 2x squared? And that's minus 5x squared. And now we can answer this. So x times what gives us negative 5x squared? That's negative 5x. And then here we have negative 5x times 1 is going to be negative 5x. And then now we go diagonally again, and we're adding when we go diagonal. So negative 5x plus some number of x's is going to give me the corresponding x term here, 5x, and that's going to be 10x. And if you're never really sure, you can always double check. Negative 5x plus 10x does give me 5x. So now we can answer this up here. X times what gives me 10x? That's 10. And then finally we can multiply to get this last box. 10 times 1 is 10. Now you'll notice here that our constant value in this bottom right corner doesn't match with the constant value in our function. When that is the case, there is a remainder. So we're going to go diagonally once again, and we want to see, okay, 10 plus what gives me 7? Well, in this case, it's a plus a negative 3. So the negative 3 is actually our remainder here. So when we write out our function, which remember our answer is this on top, and then now it's plus with the remainder, it's going to be 3x squared minus 5x plus 10, then minus 3 over whatever we divided by, x plus 1. And that is our answer. So let's go over, we'll go over a couple more. We'll go over 2 more, just so we can get a good base for this. All right. So again, first step, whatever we're dividing by, we're going to put it here on the left. So x, and this is a minus 3, so we're going to want to make sure to put negative 3 here. Okay? So if there's a minus, just make sure you put the minus there. You have to show it. And then the 2x cubed is going to go in the top left box, whatever the first term is. And again, we're going horizontally and vertically, so that's multiplication. So x times something gives me 2x cubed. That something is 2x squared. And then I can answer this one down here. 2x squared times negative 3 is negative 6x squared. And then we'll go diagonally. Remember, now we're adding, so I want to look at this, since it's x squared, I want to look at the x squared here. I think negative 6x squared plus some number of x squareds gives me negative 4x squared, and that's going to be 2x squareds. And I hope you've noticed so far that when we go diagonally, the variables must be the same kind of variables. Because remember, we can only add like terms. So if you have an x squared down here, you have to have an x squared up here. Okay? So negative 6x squared plus 2x squared gives me negative 4x squared. So I'm good there. Now I can answer this top one here. X times something gives me 2x squared, and that something is 2x. And then I can answer this down here. 2x times negative 3 is negative 6x. And then diagonally again. So I know that these two boxes need to add up to this x term here now. So negative 6x plus 3x is going to give us negative 3x. And then we can answer this up here. So x times what gives me 3x? That's 3. And then finally down here is negative 3 times 3 is negative 9. And it looks like I'm going to have a remainder here because negative 9 does not match up with 1. Like I said, we're going to get a remainder more often than not. So we're going to want to go diagonally once more and think negative 9 plus something gives me 1. Well, that something is 10. So my answer here, again, it sits here on top, is going to be 2x squared plus 2x plus 3 plus 10 divided by x minus 3. Just like that. And that's our answer. Let's go over one more just for I don't know, for something. So here we have 2x cubed minus 4x squared minus 10x minus 20 divided by x minus 4. So hopefully we are getting more comfortable with this. So we have an x minus 4. We're going to put that right here on the left. So x negative 4. And then whatever our leading term is, put right here. So 2x cubed. Now we're ready to start filling this table out. So x times something gives me 2x cubed. That is going to be 2x squared. Negative 4 times 2x squared is negative 8x squared. And now we want to go diagonally. When you get to the bottom, you want to go diagonally. So this is my x squared term, so I'm looking at my x squared term up here. Negative 8x squared plus something needs to give me negative 4x squared. That's going to be 4x squared. And again, if you ever want to double check, negative 8x squared plus 4x squared gives me negative 4x squared. Now we can answer this up here. X times something gives me 4x squared. That's going to be 4x. And then negative 4 times 4x is negative 16x. And again, we want to go diagonally. So now we're looking at our x terms. So negative 16x plus something gives me negative 10x, and that's going to be 6x. Because remember, these two need to add up to this. And then let's see, x, I could fill out this. X times something gives me 6x. That something is 6. And then negative 4 times 6 is negative 24. And again, you see it doesn't match our constant. So we're going to want to go diagonally once more. And negative 24, what can we add to it to get negative 20? That's 4. So our answer, here up on top, we have 2x squared plus 4x plus 6 plus 4, our remainder, divided by x minus 4. So if you need to, we just went over 4 examples of different kinds of what you'll see. If you need to, you can go start at the beginning and watch these again. This can be pretty tricky, so just make sure you get comfortable with this. And that's all I have for y'all. So have a good day, and let me know if you have questions. Bye.